Back, let us look at another example on application of trig functions in a right angle triangle. So guys, here I have a scenario where I have a 50 feet pole and there is a vertical antenna on top of that 50 feet pole, and it says further that the vertical antenna it subtends an angle of 10.5 degrees at a point on the ground, at a point A on the ground, which is 75 feet away from the pole. So from all this given piece of information, we have to figure out the length of this vertical antenna, which is over the 50 feet pole. So let us try to draw a figure for our reference, and from there it would be easier and more clear for us to figure out the length of that vertical antenna. Okay, so I have a vertical pole. Let's say this is my vertical pole right here. Let me try to draw a better straight line. So I have a vertical pole right here. Guys, this pole I already know is 50 feet. And then let us say this is my horizontal ground here. And then there is this vertical pole, vertical antenna right here. Let us try to draw it like just with a vertical line. So this is my vertical antenna. And then the angle, so this is say point A on the ground, which is 75 feet above, 75 feet away from the foot of this pole. Okay, so guys, this is my 50 feet pole, and it says that this angle, this vertical antenna, so this whole thing is an antenna. So this is an antenna. It subtends an angle of 10.5 degrees at this point. So well guys, you have to be careful with the wording. It is not telling me angle of elevation or depression. It is using a different word. Here it's using a word subtend. So this is how it's going to look like. This whole antenna, so it's going to look like this. This is the angle that they are telling us, 10.5. That is the angle subtended by this antenna, vertical antenna, at this point A on the ground. And it is 10.5 degrees. Guys, this is the given piece of information. Based on this, we have to figure out the length of the antenna, and let us call that length to be L. Okay, so let us say L is the length of the antenna and L is what we have to figure out. So how are we going to set this up? Guys, keep in mind, again, we can think of two right triangles here. This is a bigger right triangle. Let me call it A, B, and C. That is one of the right triangles. I can kind of think of this as, I can join this like this, and this is like a right triangle. And then I have another right triangle, the smaller one, and let me call this D, so which is ADC. But there is one thing that I don't know, guys. I don't know this angle. So let me call this angle alpha. You can call it theta, alpha, beta, whatever you like. So what I'm going to do here, there's no direct way for me to find the length of this antenna. So what I'm going to try to do first here is, I'm going to first try to find the value for this angle alpha. Once I have that, then I should be in a better position to figure out this length. Okay, so how are we going to figure out this alpha, the value for this angle? So for that, guys, I'm going to focus on the triangle ADC. And in this triangle ADC, I have the if this is my reference angle, we got to think of this as a reference angle. Then this is my adjacent and this is my opposite. What is the trig ratio that connects or that relates opposite and adjacent? And the answer to that is, guys, the tangent of the angle or tangent function or tangent trig ratio involves opposite and adjacent. So I'm going to write tangent of alpha equals to opposite over adjacent, and opposite in this case is 50. Keep in mind, I'm just looking at the smaller triangle, smaller right triangle. Okay, so one thing at a time. 50 divided by 75, that means tangent of alpha is 50 over 75. So from this equation, we can figure out the value for alpha. Guys, we got to use the inverse key in our calculators to figure this out. Of course, we need a calculator for this. So you got to type in tan inverse of 50 over 75. And when we do that using our calculator, I got 33.7 degrees. Okay, you can round to on one place of decimal. Okay, so that is my alpha. That is the value of this angle alpha, which is 33.7 degrees. Now let us try and see how we can find the length of this antenna. Guys, a common mistake that I see students sometimes make is they kind of consider triangle A, D, and B. But that triangle is not going to be useful for us. Why? Because this angle is not a right angle. This is not a right angle. So we cannot really use any of the trig ratios or trig functions for this triangle ADB because it is not a right triangle, and trig ratios right now that we have been using only work for a right triangle. So keeping that in mind, guys, what we can do is we can use the trig ratios for ADC, which we already did here, and we can also use the trig ratios for the bigger right triangle, in this case, which is ABC. So let us use the trig ratio for the triangle ABC. Again, we don't really need to worry about the hypotenuse, so we don't really need to use the sine or cosine because both of them involve hypotenuse. Okay, then what is the third one that is left is the tangent one. So we're again going to use the tangent. So let us use the tangent function. So tangent of, but this whole angle now. So we got to add this angle, 33.7. I got to add the 10.5 because for the bigger right triangle, this whole angle is going to be my reference angle. So that is, it is very important for us to, once we figure out the value for alpha, we got to add both the angles to get the new reference angle for the bigger triangle, bigger right triangle ABC. Okay, so once we add this, what do I get? I get 44.2. That is this angle right here, 44.2. So tangent of 44.2 is going to be opposite over adjacent. But opposite is this whole length here now, right? This whole length B to C. But B to C consists of two parts. It consists of this vertical antenna and then the pole. So vertical antenna is, we are denoting it by L. So it is L plus 50. 50 for the vertical pole and, sorry, the vertical pole, yes. And then this has to be divided by the opposite, which in this case is the distance, how far is this point A from the ground, from the base of the pole, which is 75. So 75 right here. Guys, this is a simple equation which we can solve. It involves just one variable. So let us go ahead and solve this equation. To solve this equation, guys, of course there's more than one ways, but the easiest and the best way is to do the cross multiplication. So when we cross multiply, we get L plus 50, because 1 times L plus 50 does not change. L plus 50 equals to 75 times tangent of 44.2, right? And to get L by itself, we got to obviously subtract 50 from both sides. L equals to 75 tangent of 44.2 minus 50. I'm going to use my calculator for that. Once I use my calculator, I got something close to 22.93. Of course, the units are here, so feet. So that is the length of the antenna that we wanted to figure out. Okay. So guys, this is another example on applications of trig functions for right angle triangles. So we have to first draw this, and then from there we can figure out what is the missing piece and what can we do, or what trig functions we can use to find those missing pieces. In this case, it was slightly different than the other two examples that we have seen. Why? Because here we had to first figure out the angle. Once we figured out the angle, then we could use again the tan function to figure out the length of the antenna. Okay guys, I will see you next time with another example. Till then, take care and keep practicing.